Hello and welcome to our lesson on some formulas. To wrap up our module on radicals, we're going to look at three formulas. Two of them I totally understand why they're in this module. The third one doesn't really belong with radicals, but there really isn't another place to incorporate this random formula, and I want to make sure that you see it before you move on to college algebra. So let's talk about these formulas. The first one I think we may have even seen before, but just in case, it's the Pythagorean Theorem. So when I say Pythagorean Theorem to you, hopefully something's popping into your head. The Pythagorean Theorem formula says that a squared plus b squared equals c squared. So if I said, what is the Pythagorean Theorem, that is the question, or that is the answer to that question. It is that formula, a squared plus b squared equals c squared. But what is it for? The purpose of this formula is to be able to find the length of a missing side of a right triangle. So if I know two sides of a right triangle, I can find the third side using that formula. So in that particular formula, A and B are interchangeable, which means it doesn't matter which one is which, but C is important. It has to be distinguished as the longest side. So a right triangle, if you have forgotten, will look like this, where it has a right angle, and that right angle is signified by that little box in the corner. And A and B are the two sides. We call them the legs. They're the two sides that make that right angle. So they make that perfect L, they make that perfect corner in that triangle. So I could have put A here, B here like I did, or I could have put B here and A here. They're interchangeable. So those two sides are the legs, and then this side is always going to be the longest side because it is across from the biggest angle. The 90-degree angle is the biggest one in that triangle, and that one has to be C, and that's the one we call the hypotenuse. So we call this the hypotenuse. And again, we call this a leg of the right triangle. We call this a leg of the right triangle. So A and B are the legs, they're interchangeable. C is called the hypotenuse. It's the longest side. Okay? So how do we use that formula? So what we want to do is identify what we're given in a triangle. In number 1, for example, we have a leg here, we have a leg here, we have the hypotenuse here. So a squared plus b squared equals c squared in this case is going to be like this. X squared and 9 squared equal to 15 squared. So in place of a, b, and c, we've got x, 9, and 15. Okay, so now we can solve for x. Let's figure out these squares first. So let's leave x squared alone, but 9 squared we know is 81, and then 15 squared is 225. So if I'm trying to get that x squared by itself, I'm trying to solve for x, right? Let me get that x squared by itself first. I'm going to subtract 81 from both sides, and that's going to leave me with x squared equal to 225 minus 81 is going to leave me with 144. Now, don't think we've talked about this in particular in this class, but if I want to solve for x here, remember everything is an opposite operation, right? So I subtracted 81 because 81 was being added. What would we do to solve from here? If x squared is equal to 100, how do I get rid of a square? And we're going to talk more about this in our next module, but what we can do is take the square root of both sides. The square and the square root are opposites. So that means x is going to be equal to 12. Now you probably knew that answer without having to take the square root, but that will come in handy. I'll show you in a few minutes. Okay, so here, what's going on with this problem is I'm missing a leg. I don't know why I'm missing a leg here. Well, let's just say that this side was 3. You're only going to be able to find one missing side. I'm going to throw, well, let's not make it 3. Let's make it, I don't think it matters, but I'm not sure why I didn't label that side. Let's pretend that 4 was already there. Okay, so we've got 4, we've got square root of 9, and we've got x. So x is the hypotenuse. This is the longest one, again, across from that 90-degree angle. So that's the side that has to be c. Okay, so instead of a squared, b squared, and c squared, in this case we have 4 squared, square root of 9 squared, and x squared. Okay, so it's a, b, and c, or 4 square root of 9 and x. And so here, 4 squared is going to make 16. What about the square root of 9 squared? And you could use your calculator if you wanted to. The square root of 9 squared is going to be 9, because the square and the square root, as I said a minute ago, those are opposites. They would cancel. Or think about this, the square root of 9 squared means square root of 9 gets multiplied by square root of 9, so that's the square root of 81, but what's the square root of 81? 9. Again, the square and the square root, those are opposites. They'll cancel. So the square root of 9 squared is going to be 9, and we still have x squared on this side. Now I can put together 9 and 16 to make 25. And so if x squared equals 25, what number squared makes 25 is 5, right? Now technically we're taking the square root of that, so x has to equal 5. All right, and then here, let's see, instead of a, b, and c, we've got 3 and x and 4. Again, the important thing to note is 4. I did not want yellow there. I wanted my highlighter. Son of a gun. Highlighter. 4 is my hypotenuse. That is C. That is the one that is across from that 90-degree angle. So 3 and x are A and B, and 4 has to be C. So we're looking at 3 squared and x squared, or x squared and 3 squared, equal to 4 squared. So 3 squared makes 9. 4 squared makes 16. I can subtract 9 from both sides, which means x squared has to equal 7, and this is why it's important to know how to solve from here. So in the previous two, I knew what number squared was going to make 25. I knew what number squared was going to make 144. I don't know what number squared makes 7, so it's important to know that I have to take the square root to solve, and that's going to make my answer the square root of 7. So there's going to be an approximation that goes along with this. The square root of 7 is about 2.6. Okay, but the exact answer I would have to use the square root to get. So not sure which answer I'll ask for in Canvas. You should be able to come up with either, but this would be the exact answer if that's what I asked for, and this would be the approximate answer, the decimal approximation, if that's what you're asked for. So the approximate answer. Okay, the exact answer would still contain the radical. The approximate answer would be the decimal. Okay? So there it is, Pythagorean theorem. Makes sense to be in a unit with radicals because we use radicals to solve. The distance formula is really just a version of Pythagorean theorem, and I'll try to show you. I don't like the distance formula myself. Too many places to make mistakes. But let me show you what it is first. The distance formula basically is used to find the distance between 2 points that are on a coordinate plane. So when you're graphing, putting points on a graph, your coordinate always has an x value and a y value in that order. And if we're looking at two coordinates, we're going to call the first x x1 and the first y y1, and then in the second coordinate x2 and y2, just because it's the second x value and second y value. So the subscripts are just telling you which coordinate we're looking at. But the distance between those 2 points can be found by taking the square root of y2 minus y1 squared plus x2 minus x1 squared, which I don't know if that's intimidating to you, but you have to subtract the y's, you have to subtract the x's, you got to square both of those differences, you got to add the squares of the differences, and then you have to take the square root of that sum. So there's a lot of places in that formula to make mistakes, but again, this is just a version of the Pythagorean theorem. It is based from the, I don't know what word I wanted to put in there. This is twice now, guys. It is a version of the Pythagorean theorem. Let's just say derived. It is derived from, it comes from the Pythagorean theorem, and I'm going to show you that. I don't know what. Gosh, I'm spaced. Okay. My bad. Alright, so let's look here. I'm going to show you how to use the formula, and then I'm going to show you how this is derived from the Pythagorean theorem. Not that you want to see a whole derivation of this, but I like to use the Pythagorean theorem in place of the distance formula, and you can choose what you like. But let me show you the formula first. So If these 2 points were graphed, we should be able to find the distance between them using this distance formula. So this is the first coordinate, which means I would call this x1 and y1. It's the first x and the first y. Okay, so again, this is an x value, this is a y value because it's the first point. We're going to call it x1, y1. And then your second coordinate here, again, this is an x and this is a y, but it's the second coordinate, so I'm going to call it x2 and y2. So the distance formula says we're going to take the square root of, in the first set of parentheses, it's y2 minus y1. So y2 is 1 minus y1 is negative 3, and that's going to be squared. Plus is in the formula, and then another set of parentheses. In the next set it says take x2 and subtract x1. So x2 is 2, and I want to subtract x1, which is a negative 1. So it's minus a negative, and that's going to be squared. And now from here, you technically could put the entire thing into your calculator. So square root of, we have 1 minus a negative 3 quantity squared plus parentheses 2 minus a negative 1 quantity squared. And as long as you get everything typed in there correctly, it's going to give you the exact answer of 5. So the thing is, you should be able to simplify by hand because sometimes it's not going to be an exact number, it's going to be approximate, and you want to be able to give me the exact radical too. So these double negatives are going to make positives here, so this is really going to be a 1 plus 3, and this is really going to be a 2 plus 1. And 1 plus 3 is 4, and 2 plus 1 is 3, and those both have to be squared. So we have the square root of 4 squared is going to be 16, 3 squared is going to make 9, and then 16 plus 9 is 25. So the square root of 25, which is why the calculator said, oh, the answer is going to be 5. Okay? Now on the next guy, again, this is x1, y1, and this is x2, y2. It's the first x and y, and then the second x and y. So the distance is going to be the square root of, that was ugly. In parentheses, y2 minus y1 would be 3 minus 6. That gets squared. Plus x2 minus x1 is negative 1 minus 5. That gets squared. And then this one, so let me just show you. Again, if you go to your calculator, square root of 3 minus 6 quantity squared plus negative 1 minus 5 quantities squared. So it gives me that decimal, which a decimal approximation is okay, but if I wanted the exact answer, you'd have to figure out what's underneath the radical. So let me just type in the part that's under the radical, 3 minus 6 squared plus, I forgot, negative 1 minus 5 squared, and it should be 45. So I end up with radical 45 and then the approximation. So you can still use your calculator. You just got to be careful about what you're putting in there. Now without the calculator, let's see here. This would be 3 minus 6 would be negative 3, and then negative 1 minus 5 would be negative 6. And so the distance would be the square root of negative 3 squared is going to be 9. Negative 6 squared is going to be 36, and that's why we ended up with 45 under the radical. So 45 actually still wouldn't, the square root of 45 still wouldn't be an acceptable answer. It's an exact form, but it's not simplified. We can break down that radical. So 45 is, let's see, 3 goes in 15 times, and then that's 3 times 5, so a 3 can come out. So we would say it's exactly 3 radical 5, or approximately, what was it, 6.7-ish? 6.7. So 3.5 or 3 or 6.7. Again, this would be the exact answer in simplified form, and this would be the approximate answer depending on what you're asked for. Now, again, that's your distance formula. Again, makes sense in this unit because we're using a radical in the process of simplifying with the formula, but I don't like that distance formula. It's not horrible, but there are lots of little places to make mistakes, especially if you're not using a calculator. And I just want to show you that this is the Pythagorean theorem, okay? So let me show you here. So the first if we were trying to find the distance between 2 points in a graph, let's say we wanted to use, let me just make up a couple points. Let's say we have a coordinate at 3, 1. Okay, so 3, 1 is one of our coordinates. And then 1, 2, 3, 4, 5, 1, 2, 3, 4. So let's go with 3, 4, 5, 6, 7, 8, 4. Where's this one at? 8 and 1, 2, 3, 4, 5. 8, 5 is our second coordinate, okay? If I wanted to find the distance between these 2 points, and I actually drew this on a graph, okay? Can you see how we can make a right triangle out of this? If I wanted to make a right triangle out of this, then I could just draw the vertical and horizontal distances between those 2 points. So here's the vertical distance between these 2 points, okay? And then here's, let me change the color. The vertical distance between these 2 points, okay? And then the horizontal distance between these 2 points right here. So it makes a right triangle, and that means you can see how we can use Pythagorean Theorem. Like, this is going to be the side C that we're looking for, and sides A and B are literally vertical and horizontal lines, things we can count. So we're going from, let's look vertically first, we're going from a y value of 1 to a y value of 5. From a y value of 1 to a y value of 5, how many units is that? It's 4 units, okay? And then horizontally here, we're going from an x value of 3 to an x value of 8. So from an x value of 3 to an x value of 8, that's 5 units. And so 4 squared plus 5 squared would have to equal c squared, right? So if I wanted to solve for c, then I would have to take the square root of both sides. So the square root of 4 squared and 5 squared is going to get me that answer. Now, the distance formula is doing the exact same thing. So in the distance formula, you have d equals the square root, right? Well, this 4 we can get by subtracting our y values. Our y values here, if I subtract 5 and 1, I get the 4. And then the 5 that we have here, we can find by subtracting the x values, the 8 and the 3. So when I'm looking at a problem like this, I'm thinking about this as the Pythagorean theorem. So let me show you here again. If our coordinates were, what was it, 3, 1, 3, 1, and 8, 5, then I know the vertical leg of my triangle and the horizontal leg of my triangle would be the distances between the x's and the y's. So in my head, I'm like, okay, how far is it from 8 to 3? That's 5 units. And how far is it from 1 to 5? That's 4 units. And then I can use my Pythagorean theorem to solve. So if I was solving, I'm just going to make up any 2 random points, okay? So let's say 5 and 9. Okay, if I wanted to solve this one, I could use a distance formula. Or I could say, how far is it on the graph vertically from -2 to 5? Well, 2 units that way and 5 more that way, that's 7 units. And then how far is it from 1 to 9 on my graph vertically? Well, from 1 to 9, that would be 8 units. So 7 squared and 8 squared is going to have to equal c squared. So if it's easier for you to look at that in terms of Pythagorean theorem, cool. If what I just said makes no sense, then forget it. Just use the distance formula because it works, okay? All right, so you got Pythagorean Theorem version 1, and then you have distance formula, which is Pythagorean Theorem version 2. And then here's our third formula we're going to look at, which doesn't really have any business being in this module. It doesn't have anything to do with radicals, but it is a formula that you need to see, and since we're talking about formulas, boom, here it is, okay? It's called the midpoint formula. Midpoint formula is used to find the midpoint between 2 points on a coordinate plane. So midpoint formula is calculating a point, okay? It's the midpoint. So what we want is a coordinate, so it's going to be in parentheses. There's going to be an x value and there's going to be a y value. To get the x value and the coordinate, you're going to take the x values that you're given and you're going to average them. So that means you're going to add your 2 x's and divide by 2. And then you're going to take the 2 y values, y1 and y2, and average them. So you're going to add them and divide by 2. Okay? So it averages the distance between the y's, and it averages the distance between the x's. So what is the midpoint between the x values, and what is the midpoint between the y values? And that's going to give you the midpoint of the whole segment. So again, this is your x1, y1. This is your x2, y2. So our midpoint is going to find the average of the x's. So we're going to add the 8 and the -2 and divide by 2. And then we're going to find the average of the y's. So we're going to add the 7 and the 5 and divide by 2. And then we get an answer. Hopefully that makes some sense. Okay? So here, 8 and -2 makes 6, and 6 divided by 2 is going to be 3. And then here, 7 and 5 makes 12, and 12 divided by 2 is going to make 6. Okay, so think about what's happening here. Is we're asking what is in the middle of 7 and 5. What's in the middle of 7 and 5? 6, right? Okay, which this is like when we found the median, right? Remember, the median is the middle of a list. Oh, that wasn't this class. That was my 142. Oh my gosh, guys, I'm falling apart. Too many classes. But you've probably found a median before. It's the middle number. What is in the middle of 7 and 5 has to be 6. Now, it's a little harder to see what's in the middle of -2 and 8 because it's kind of stretched. So if you want to find the middle because you can't see it, you add the two numbers and divide by 2. Okay? Let's try that again. Here's x1, y1. Here's x2, y2. So for this midpoint, we're going to add the x's, 3 and 2, and divide by 2. And then we're going to add the y's, 0 and 12, and divide by 2. And so this midpoint is going to equal what? Well, what's in the middle of 2 and 3 would have to be 2.5, right? And so if we take the 2 plus the 3 and 5 and divide by 2, that's exactly what we get. We get 2.5. And then what's in the middle of 0 and 12? Well, if you add 0 and 12, you get 12. Divided by 2 is going to be 6, because in the middle of 0 and 12 is 6. All right? So there it is. Not so bad. 3 pretty manageable formulas. Now, let me show you a couple of applications why some of these formulas are helpful. Places for us to apply the new learning, right? Not that you're going to necessarily do this in your real life, but here are some places where this could be useful for somebody. So number 8 here says Brian biked 10 miles east of his house and then 8 miles south from there. How far is he from his house? So east and south, I don't know if you know your directions, but it doesn't really matter as long as you recognize that east and south are going to make a 90-degree angle. So north, south, and then west and east. Although if you had them flipped, it doesn't matter. As long as you know north and south are opposites and east and west are opposites. Okay, let's make Brian here. Let's try to draw this out. There's my fancy drawing of Brian. He biked 10 miles east. So he biked 10 miles east. Let's put a 10 there. And then from that point where he got to his 10 miles, he went 8 miles south. Okay, so 8 miles south. So if he goes 10 east and 8 south, again, we're going to have a 90-degree angle in between those. And the question is, how far is he now from his house? So he started here and he started here, landed here. So how far is he from this house? From his house, from where he started? That is this distance here. We don't know it. Let's put an x there. So you can see that this is a Pythagorean Theorem problem. We can say 8 squared plus 10 squared is going to equal x squared. So this is 64 and 100, which is 164. And obviously there's no exact square root of that. Now, if we had no context, I would definitely prefer the exact answer. I would say break this radical down, but it's not going to make sense to break this down, right? If we did, let's see, 2 goes in 82 times, then 2 goes into that 41 times, so it becomes 2 radical 41. If I said how far is Brian from his house after biking 10 miles east and 8 miles south, are you going to say, oh, he's 2 radical 41 miles from his house? Probably not, because we don't really speak in radicals. So even though the exact answer is preferred out of context, when there is context, the approximate answer is preferred because it makes a little more sense to speak in decimal. So approximately how much is the square root of 164? It's about 12.8. So this is going to change. This is going to be approximately 12.8. So about 12.8 miles. So even though he's actually biked 18 miles, He didn't take the shortest distance to wherever he was trying to get. He's only 12.8 miles away from his house. Okay, so there's that. Now that this is a little off center. All right, so there's one application. Pythagorean theorem, check. All right, next one. Says the nearest Starbucks is 3 miles north and 1 mile east of GCC. If Linda is 5 miles east of GCC, how far is she from the Starbucks? So the nearest Starbucks is where it's at is given in reference to GCC, and where Linda is at is given in reference to GCC. So what I would do is draw this out on a graph. And I don't know why I'm not using my little cheat tool here. And let's go ahead and make GCC the epicenter of this graph, okay? So let's say GCC is the epicenter at 0, 0, because everything is in reference to GCC, right? So like when you're plotting points on a graph and you say the coordinates at 2, 3, 2, 3 is in reference to the origin, which is 0, 0. Okay, so let's put GCC at 0, 0. And then let's plot Starbucks. So Starbucks is, remember, this is north, south, west, east. And if you flipped them, it doesn't matter as long as north and south are opposites and east and west are opposites. So Starbucks is 3 miles north and 1 mile east. Where is Starbucks going to be? So 3 miles north and 1 mile east would put Starbucks right here. So Starbucks is going to be at 1, 3. And then Linda, let's put Linda on the map here. Linda's 5 miles east of GCC. So 1, 2, 3, 4, 5 miles east would put Linda right there. So Linda is at 5, 0. So the question is, how far is she from Starbucks? The question is, what is the distance between these 2 points? That is the question. So we've got two different ways we can look at this. If you want to make the right triangle and use Pythagorean theorem again, you can. Since you also have 2 coordinates, if you wanted to use the distance formula, then you could do that as well. And just so you have variety in your notes, I'm going to go ahead and use the distance formula on this one. So we want to find the distance. Distance between 1, 3 and 5, 0. So x1, y1, x2, y2 is going to make our distance the square root of y2 minus y1 is going to be 0 minus 3. That gets squared. x2 minus x1 is going to be 5 minus 1, and that gets squared. So we're looking at negative 3 here and 4 here. So the square root of negative 3 squared is going to be 9, 4 squared is going to be 16, and we've seen this already a couple times. The square root of 25 is going to be 5. So Linda is 5 miles from the Starbucks. 5 miles from the Starbucks. Okay, not terrible. Hopefully, makes sense, the picture I put out there for you. All right, last one. Says PQ is the diameter of a circle. If P is located at negative 2, 5, Q is located at 6, 7, what are the coordinates for the center of the circle? So let's draw this out. Nope. Got to be a little bit better. There we go. Okay, so I have a cheat tool, but if I don't make something that looks like a circle, it won't create it. All right, so here's my circle. It says PQ is the diameter of a circle. So a diameter cuts a circle in half. A diameter is going to look like that. It's going to cut the circle in half, okay? So it says, just kidding, that P, if PQ is the diameter, that means this segment PQ cuts the circle in half. So P and Q would be those endpoints of that circle. So P is at negative 2, 5, and Q is at 6, 7. It says, what are the coordinates for the center of the circle? Well, the center of the circle happens to be the middle of that segment. So you can see we are just trying to find the midpoint. So for the midpoint, we want to, let me just rewrite the coordinates over here. We have negative 2, 5, and 6, 7. We want to find the midpoint where, again, this is going to be your x1, y1. This is going to be your x2, y2. So for the midpoint, we're going to add the x's to find out what's in the middle of negative 2 and 6 and divide by 2. And then we're going to figure out Hopefully we don't need a formula to figure out what's in the middle of 5 and 7, but we can use it. Let's see, -2 plus 6, that's 4 units, divided by 2 is going to be 2 here. And then 5 and 7 makes 12, divided by 2 is going to make 6 here. Because in the middle of -2 and 6 is going to be 2, and in the middle of 5 and 7 is going to be 6. So that is our midpoint. Those are the coordinates for the center of the circle. Okay? Not so bad, hopefully manageable. Hopefully you've got enough here to go off of for your final practice for the module, and enough again to go off of for the quiz that's going to be coming up. But as always, if you have any questions and need some help, then just reach out. All right, guys, take care.